Hi, I am Lopa Sen. Welcome back to my channel Electronic Science Tutorial. I will start a new lecture series on NTA UGC NET and West Bengal SET exam for electronic science subject. Those who are not follow my channel, please follow my channel. If you like my channel, then please like, share and subscribe my channel. So let's start our class. Welcome back to my channel with a new lecture series on semiconductor device and PN diode, that is diode equivalent circuit. It is very much important topic for you guys, those who are trying to crack NTA UGC NET exam for electronic science, and also it is very important topic for West Bengal SET exam. In Unit 1 of the electronic science syllabus, this topic is placed. In previous class, I already talked about the various topic of semiconductor device and PN diode. Those who are not check out my channel, please follow and do like, share and subscribe my channel. So, let's start our class. First topic we covered in this section, that is the diode equivalent circuit. First topic. First is piecewise linear equivalent circuit. So this is the graph. This is the graph and this is the piecewise linear equivalent model, and this is the piecewise linear characteristics of a PN junction diode. Okay, there are various techniques for obtaining an equivalent circuit for a diode, and this straight line segment, from this straight line segment, the resulting equivalent circuit is called piecewise linear equivalent circuit. It should be obvious that the straight line segment do not result in an exact duplication of the actual characteristics, especially in the knee region. So, the resulting segments are sufficiently close to the actual curve to establish an equivalent circuit that will provide an excellent first approximation to the actual behavior of the device. Okay, so this is the piecewise linear characteristic curve, and this value is 0.7 volt. If a voltmeter is placed across an isolated diode on the top of a lab bench, 0.7 volt reading will not be obtained. Okay, the battery simply represent the horizontal offset of the characteristic that must exist to establish this conduction, and this resistor value is 10 ohm. Okay, and this is the ideal diode. So this is piecewise linear equivalent model, and this is piecewise linear equivalent characteristics. Next we talk about the simplified equivalent circuit, and this is the graph. For most applications, the resistance R is sufficiently small to be ignored in comparison to the other elements of the network. So if we removing the R from the equivalent circuit, that is from the piecewise linear equivalent circuit, what we get, that is in this portion R is 0 ohm. Okay, so if we neglect this R value, we get this simplified model, that is this is the 0.7 volt and this is the ideal diode, and here we neglect the resistance. Okay, so this is the simplified equivalent circuit model. It states that a forward biased silicon diode in an electronic system under DC condition has a drop of 0.7 volt across it in the conduction state at any level of the diode current, and this is called the simplified equivalent circuit. Okay. The next diode equivalent circuit is ideal equivalent circuit. Now, the R resistance has been removed from the equivalent circuit. Let us take the analysis a step further. That means it established that a 0.7 minus voltage level can often be ignored in comparison to the applied voltage level. In this case, the equivalent circuit will be reduced to that of an ideal diode only, and this is the ideal diode. And here we can neglect the Vk voltage is also and the R resistance is also, and this is the graphical representation of Vd versus Id graph, and this model is called ideal equivalent model or ideal equivalent circuit. So first we consider the piecewise linear equivalent circuit, then we can consider simplified equivalent circuit, and the last portion is ideal equivalent circuit. So these three equivalent circuit is called the diode equivalent circuit. Okay, these three topics are very much important for NTA UGC NET, right? So here we end today's session. Thank you. With this, we have come to the end of our session. Thank you friends. If you like my video, then please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.